Okay, so now let us start the second part. I want to talk about implicit differentiation. First of all, let us see what we mean by an implicit function. I think a simple example might be a relation like this, because so far, if I write a relation like this, it is more or less a little bit different, because when we talk about functions, we have used to have y alone on the left hand side and everything on the right. For example, if I write y equals to square root of 3x plus 2, this is the usual way of writing a function. And then it always guarantees that this equality represents a function. That's why it is very common. I will talk about that, what do I mean by this. But this is called explicit function. The function that you have a relation, the y alone is on the left and everything else is on the right. That's called an explicit function. But we also have implicit relations. I will not immediately call them functions. This is an implicit relation. It means that the relation to y and x are not explicit as this case, but they are implicitly related. So if I have a mixture of x and y on both sides or one side, that's called an implicit. It's very soon to say implicit function. Why is that? Because I don't know how many of you have seen the graph of this relation. It's a circle centered at the origin with radius 1. So if I draw that, I hope that you can see this graph, if the radius is 1 and the center is here, this is the graph of this relation. What does it mean? It means that you highlight all the points whose coordinates fit this relation. If I have a point whose coordinates fit this relation, for example, 1 over 2, square root of 3 over 2. Yes, this fits this relation. If I raise this to power 2, it is 1 over 4. If I raise that one to power 2, is 3 over 4. 1 over 4 plus 3 over 4 is 1. So this means this is one of the highlighted points on this setup. If you highlight all possible points that fit, it will become a circle automatically. That's the meaning of the graph of this relation. But you immediately realize this graph is not a graph of a function. Why is that? Do you know? Yes?
Because for 1x you get 2 y's.
Yes, the function, do you remember when we were talking about functions, I told you that if you have some numbers here and some numbers here, if you want to associate them, so every one of them should be assigned to exactly one of these. So this is not possible. This is not a function. That if I have one single value which is assigned to different values, this is not a function. So that is the reason that is not a function. Because, for example, for this particular x, I have 2 y coordinates. So it means that this x here goes to here y1 and y2. So that's not a function. Okay? And the problem, if I don't have a function, I am a little bit in trouble, because the notion of limit, the notion of derivative and everything was defined for a function. Okay? So that is the problem here. Okay, so how can we do that? The problem of implicit differentiation is that even though the whole picture is not a function, but I can restrict my domain so that I can pick up a piece of a function from the whole graph. Yes, for example, if I clean everything here, do you agree the remaining part is a function?
Yes.
Yes, because now every line either does not intersect this part or intersect at most at one point. So it's a function that by restricting the whole graph to this part, I have a function. Okay? Or, for example, is this a function? If I clean only this one, I am left with that one. Is that a function? Yes, that's also a function. Okay? So if
the bottom part,
you can also pick up the bottom part.
how do you clean it?
No, I'm not cleaning it. I am saying that if I have the full circle is not a graph, is not the graph of a function. But if I take one part of it away, even though that part is left intact, then I have a function.
I understand, but they belong to the same domain, right?
The domain is the same.
How do you?
So let me, for example, in this case, if I want to make it explicit, what should I do? I write y squared is equal to 1 minus x squared. Then if I take the square root to make it explicit, y becomes a square root but plus or minus. Okay? Okay, so this means that if I restrict my domain, for example, from -1 to 1, and I say that, okay, this is part of the whole graph, which is represented by the positive one only, because y's are positive. And then if I take the negative one, it will be the lower.
Okay.
Yes? The whole point is that here, if I ask you, if this is given, if I ask you what is y prime, okay, it means that you have to think in this way. For example, usually I ask y prime at a point, for example, 1 over 2. This means that if I take 1 over 2, then I have 1 point here and 1 point here. And I calculate the derivative at this 1 point. So it means that either I have to consider this neighborhood, it means that I am working with this part of the graph, yes, or I have to restrict it to this part, okay? Then I can talk about y prime of 1/2. Okay, but the point is that the notion of implicit differentiation is that if I can do it, of course I can continue the problem. Okay, I can differentiate it. How can I differentiate it, by the way? I put plus or minus, but this is the chain rule. I take it u. Square root of u is 1 over 2 square root of u. But I have to multiply by u prime, which is minus 2x. So it gives me, if it is minus, it becomes minus, and this will be the other way around. So it becomes plus or minus again, x divided by square root of 1 minus x squared. So in principle, if I can find y in terms of x, and then of course then I can calculate y prime as I learned before. But if this relation is complicated, there is no way that I can find y explicitly in terms of x. But still, the question is that, is there any way for me to find the derivative without doing these explicit calculations for the hard ones? The answer is yes, and we call it implicit differentiation. Okay, so what is the idea? The idea is that I differentiate both sides. Again, this is always the convention. Y is the dependent variable, the y coordinate, and x is the independent variable. So it means that I will differentiate with respect to x. But one thing you need to remember is that x is independent. It can take any value you want, but y depends on x. Usually they don't write dependence of x explicitly, but this is the way you need to think. Okay, is equal to 1. And then I start differentiating exactly according to what we learned. It means that I differentiate both sides. But be careful, prime here means derivative with respect to x. Okay, now can you help me? This is the sum. So what if I calculate this? The derivative of this one becomes 2x plus. Now can you tell me what is the derivative of y squared of x? Yes?
2y
2y of x
times y prime.
times y prime. Can you see that? Because that's the chain rule. This is a function of x. X is independent. There is nothing inside it if you want to think it that way. But y is a function of x. So it is if you want to give the role of u, you can give the role of u to the whole combination. This is u squared. And if I ask you what is the derivative of u squared, as we learned, it is 2u, but multiplied by u prime. And then the right hand side is 0. Okay? And then I am looking for this question mark. Okay? So you move this to the other side, so it becomes 2yx multiplied by y prime of x is equal to minus 2x. Because I am looking for y prime, I have to isolate it on the left. So I divide everything by this factor. So this becomes y prime of x is equal to minus 2x divided by 2y of x. And if I simplify it, y prime of x becomes minus x over y of x. If you don't mind, usually we don't write. I wrote it for you to understand that inside y there are some relations of x. But this is what you write. Yes, but there is a condition. If I want to divide both sides, I have to be certain that this expression is not 0. Because if it is 0, I am in trouble. So it means I cannot divide. Okay? So that is the implicit differentiation. Okay? And if you compare it with this one, this is understandable, yes? What is this one? This is your y. Okay? So depending which y you are doing, you either get the positive one or the negative one. So that is exactly minus x over y. Yes? Is that understandable? Okay. So this is called implicit differentiation. It might be a little bit confusing in the beginning, but you will soon learn it. Sometimes they might say, I haven't seen those questions in the exam, they might say that take y to be the independent variable and x dependent. So it means that you need to switch the role of x and y if that is happening. Okay? But let us do some practice because this needs a lot of practice. For example, if you don't mind, let me skip number 1 and let us do number 2 and 3. These are good ones. So let us do it together here on the board. But I will do it step by step because sometimes it is confusing. Okay, so 3x to power 4 times y squared minus 7x y cubed, and then it's equal to 4y minus 8x. So remember, if you are having trouble, rewrite it by writing y of x. But remember, always, if they say find y prime, they mean that y is the dependent variable, x is independent. So they are asking about the derivative of y. Okay, so what should we do? Let me write all these steps. The first thing you do, you differentiate both sides with respect to x. This prime means differentiation with respect to x. If you want, instead of prime here, you can use this Leibniz notation, d dx. It means that you are telling to the person who looks what you are writing that the differentiation is with respect to x. Okay, but there is a difference here, and there is a prime up there, so I have to do it case by case. So it becomes 3x to the power of 4 y squared prime. You can do this faster, but the first one I want to be patient and do all these steps for you. This is the way you have to think. If you can do some part of it in your head, that's even better. And please interrupt me if there is something I am making wrong or you don't understand. Is that good? Okay. Now, how do you think here? This is a multiplicative constant, so in principle 3 goes out, and then I have to differentiate this one. Okay, so let me be patient and write all the details. You can skip these parts, okay? So the 7 goes out, 4 goes out, so there is nothing here, so it's y prime. And then 8 goes out, and then I have x prime. Okay, so if I want to write all the details. Okay, so the right hand side is easy. There is nothing I can do here, but this one is 1. So the right hand side is finished. But now I want to hear from you. I copy and paste this 3. What should I do here? I have a prime on, what is this?
Product.
It's a product. So it's a prime on a product. So what is the product that's on the board? It is the derivative, so I open a pair of brackets, the derivative of the first one multiplied by the second one itself plus the first one multiplied by the derivative of the second one. Do you agree? Okay. Where is the... So let me open up a little bit of space here. Okay, that is a product rule applied here. But this one is also another product rule. So it becomes the derivative of the first one multiplied by the second one itself plus the first one multiplied by the derivative of the second. Okay. But now tell me, what is the derivative here? I copy and paste 3. This one is, what's that? Come on, say something. 4x cubed. Then multiplied by y squared. But this one you have to be a little bit careful because y, it means x dependence is inside y. So if I copy and paste this x to the power of 4 part, but what is the derivative of y squared? Remember, y depends on x. So it is 2y, but it is not finished because y depends on x. You have to multiply by y prime. Is that right? Okay, and then continue. So minus 7, the derivative of x is 1, so it becomes y cubed. Again, plus x times the derivative of y cubed is 3 y squared, but y prime. And on the right hand side, I will have 4y prime minus 8. It is usually a mess. Okay, so that is natural, normal. But you have to find y prime. Don't think it's a hard problem. It's not a hard problem because the power of y prime is always 1. And if you want to calculate it, you have to write a lot, messy things, but it is simple. For example, what do you think? I will multiply this 3 in, I will multiply this 7 in, and arrange them so that I can solve and find y prime. So if I multiply 3 in, so it becomes 12, x to the power of 3, y to the power of 2, plus, I have a 2 here, and a 3 will be multiplied there, so it becomes 6, 6 what? X to power 4, y prime. Yeah, if you see I am doing something wrong, please let me know.
That's correct.
That's correct. Okay, then I will multiply minus 7 in, so it becomes minus 7y cubed, and then minus 21 xy squared y prime. On the right hand side I have 4y prime minus 8. Yes? And now I am looking for my y prime. So y prime is my unknown. So you have to bring y primes to the left, the terms without y prime to the right, as if you are solving an equation. Yes? Okay, but let us do some part of it in our head. This term has a y prime. This term has a y prime. I keep them here. But this one, I move it to the other side, this one. Yes, because it has y prime. It becomes negative for y prime. And then I factor a y prime out. Okay, let me do this one in 2 steps. These are the terms including y prime. Move it to the left. The terms without y prime to the right. So this will go to the right. So there is a minus 8 left there. This one will be to the right. And this one also moves to the right. With changing the sign, of course. Yes? And then what do? There is a y prime, y prime, y prime. You factor it out. And if you don't mind, let me write it in different order. It doesn't matter, of course. Yeah, you see, it seems messy, but it's straightforward. And then I want to find y prime, so I have to isolate y prime here. So I have to divide everything by this messy factor, whatever it is. We just write, okay? So y prime is equal to 7 y cubed minus 12 x cubed y squared minus 8 divided by 6x to power 4y minus 21x y squared minus 4. That's it. Of course, this shouldn't be 0. Yes? So this is called implicit differentiation. So in principle, could I teach you this one first and then the chain rule or not? Could I?
What's the question?
Could I teach implicit differentiation first, then teach you the chain rule?
No.
Why not?
Because they use chain.
Because we are using chain rule. Do you see where? Yes? When I have y squared and I differentiate it, I don't write 2y, I write 2y prime. So it means that I'm using the chain rule. Is that okay? So it's always the case. If you get y prime squared, it means you messed up. There is no y prime squared in implicit differentiation here. Okay, so be careful about that point. Okay, let me do one more and then we skip. I want you really to sit down because these are, you have to practice to be fast as well. So the next one is a little bit simpler, I mean, in writing, but it is good to know. So number 3 I am solving. X cosine y plus y sine x equals to 1. I want to find y prime. Okay, so if you don't mind, let me change my notation so that you also get used to both. So what I do first, I differentiate with respect to x. I hope that you are not confused, okay?
What's the difference between d dx and dy dx?
No, dy, this is my hypothetical
no,
y.
dy.
No, dy, dx means y prime.
Okay.
Only. But here d dx means whatever here is, I am differentiating, but with respect to x. Okay, I just want you to, if you are not happy with that, just put this symbol. Of course, the rest of it I will use the normal method. So, the right hand side, what is the answer? I hope that you are not confused. D dx means just the derivative. The derivative of the constant 1 is 0. But here, there is a sum. So the derivative will be the derivative of the first one. So I'm changing the symbol. In principle, you can write d dx. And then plus the derivative of the second one. Okay, so I want to hear from you. What do you think about the first part? First term. Which rule applies first? Product. That's a product. So it becomes the derivative of the first one, 1 times the second one, plus the first one times, let me write it, the derivative of the second. And then plus, this is also another product rule. The derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one, and the right hand side is 0. Okay, so here I copy and paste the there. There is no prime there, so cosine y. But what is the derivative of cosine y? The formula is on the board. The derivative of cosine x is minus sine x. But this is not cosine x, it is cosine y, and y is a function of x. So can you tell me what should I write here? I would write x, copy and paste. For this one, help me. Minus sine y, but multiplied by y prime. That's the only thing you have to be careful. And this I copy and paste. And this one, it's just a normal formula in the table, which is cosine x. And it is 0. Yes? And then what I'm supposed to do now, I have to arrange it so that I can factor y prime out. So this term contains y prime. This term contains y prime. So let me factor y prime out from these two. Sine x is left from there. Minus sine y times x is left from here. Yes? These two terms, they don't have y prime. I move them to the other side. So it becomes minus cosine y minus y cosine x. And then finally I want to isolate y prime. So y prime becomes, let me factor a minus sign. So this becomes cosine y plus y cosine x. And I divide it by sine x minus x sine y. So that's called implicit differentiation. Any questions? Okay. The next topic is very simple. That's the notion of higher order derivatives. So you already know it, yes? Higher order derivative means when you take the derivative, you get a function. You differentiate it once more, you get the second derivative. You differentiate it once more, you get the third derivative. Yes? So that's the meaning of higher order derivatives. For example, in Newton's law in physics, F is equal to ma. A is the acceleration. So acceleration is the second derivative of the position. Yes? So you differentiate the position, you get velocity, and you differentiate velocity once more, you get acceleration. So that's the Newton's law. So sometimes we really need higher order derivatives. And when we come to Taylor polynomials in this course, you will see that the higher derivatives are very, very important because it allows us to approximate any function with polynomial functions. So the notion of higher order derivatives is important. But the idea is very simple. I give you a function. If I ask you find the third order derivative, you differentiate it 3 times one after the other. That's the idea. Yes. So for example, if I want to show, and the symbols that we use, by the way, let me also mention. If I give you a function y, for example, you know that when I say the first derivative, I put a dash on it. Second derivative is 2 dashes. Third derivative is still 3 dashes. But when I say the fourth derivative, I can put these dashes, but this has become messy. This is why after that we write this. And we put these pairs of brackets because if we don't, it means y to power n. To prevent that this is not y to power n, we put another one here. So it means that if I want to write the fourth derivative, it is not common to write like this. It is common to write for the fourth derivative in a pair of brackets. So that's the only thing you have to know about the notation. And so what I have written here, you can see the notations are. For example, can you see the question number 7? Determine the derivatives of this function of all orders. Okay, and by the way, this is not usually easy to find the functions of all orders. Some functions, when you differentiate them, they become messier and messier. There is no regular pattern for them to be able to guess. But for example, this function, I hope that you can see, is extremely simple. So if I give you f of x equals to what? X to the power of 3 plus 2x squared plus 1. Yes, is that right? Yes. So now, if I ask you what is the first derivative, it becomes 3x squared plus 4x. If I ask you what is the next derivative, the second derivative, it becomes 6x plus 4. If I ask you what is the third derivative, it becomes 6. And what do you guess for the derivatives after that? 0. All of them are 0. Because if I take one more derivative, so it means that f of order 4, the derivative of order 4 is 0. But not only this one is 0, if the fourth order is 0, of course, this one is also 0 if n is greater than or equal to 4. By the way, I forgot to say that in this notation, you might also see the 0th order. The 0th order derivative, it means that you haven't done the derivative at all. So what does it mean? Yes? It means that is the function itself. So this notation is also common. Any questions here? Yes?
I was wondering in what area would you use derivative over more than 4?
No, I told you, later we have a concept called Taylor polynomial. And Taylor, when we talk about series, for example, if I ask you what is sine of, we will learn a little bit today. For example, if I ask you what is sine of 30, you will answer me it's 1/2. But if I ask you what is sine of 31 degrees, that's not exactly 1/2. We want to find an approximation. But if I go to higher and higher order derivatives, I can make this approximation better and better. Okay. We will talk about that. Yeah. Yes. Okay, any questions? Okay, so there might be different questions. For example, the next one, question number 8. So sometimes it is possible to find a formula for any order derivative, but it is completely accidental. It depends on the function. For example, this example that I have mentioned here, I want to find all possible derivatives of this function. For example, if you give me n, if n is given, I want to be able to know what is a formula for the nth order derivative, whatever it is. It's not always possible, but some functions reveal some patterns that you can do that. Okay, for example, the first derivative. First of all, tell me, if you want to do the first derivative, what do you do?
Chain rule.
Chain rule, how?
Well, so the function is essentially 1 plus x, all of that to the power of
Minus 1. That's very good. Because some people, that's so you did it the good one. Some people try to do it by the quotient rule. That is also correct. That's not wrong. Because it's a quotient, so you can use the quotient rule. But if possible, try to avoid the quotient rule, and that is the reason that's a mess. Yes, if it is possible. And in this, it is possible. Okay, so I don't want to use the quotient rule. I first prepare it for the chain rule. I bring the whole combination up. So in principle, there is an invisible 1 up there. So when I bring it up, what happens? It becomes 1 plus x to power minus 1. Now, I can use the chain rule to take the first derivative. Can you tell me what is the first derivative? Take this u in your head, so it becomes u to power minus 1. And the derivative minus 1 goes down, u to power minus 2, but I have to multiply by u prime. But the good news is that accidentally u prime is what? 1. Well, that's very good. So what happens? It becomes minus u to power minus 2 multiplied by u prime, but u prime is 1. This is u prime, yes? But now, can I do the second one? What happens? Again, take this u in your head. You will have minus u to power minus 2. So if I want to differentiate, minus 2 goes down, u to power minus 3 multiplied by u prime, but u prime is again 1. So u second becomes 2, 1 plus x to power minus 3. Yes? Now, can you do the next one? Then you will see a pattern reveals itself. So what is the third one? Minus 6, 1 plus x to power minus 4. Can you see that? But what is your guess now? If I do it n number of times, okay, this 1 plus x in the pattern is always the same. But can you tell me what the exponent is? You see, this is the first derivative, it is minus 2. It's the second derivative, it's minus 3. It's the third derivative, minus 4. So it becomes minus n plus 1. Yes? Another problem that I have, one of them is negative, the next one is positive, the next one is negative, and the next one will be positive. The next one, so it is going positive, negative alternatively. So how can I take care of that?
Minus 1 to the power of n.
Yes, minus 1 to the power of n. Yes, because if n is 1, this becomes negative 1. It takes care of this minus sign. If n is 2, this becomes minus 1 to power 2, which is 1. And then the next one will be negative. So this makes the negative positive alternative. But then the coefficients, the coefficient that I haven't written here is 1. The next coefficient is 2. The next coefficient is 6. What is the next coefficient? 24. So are these numbers familiar to you?
And factorial.
It's factorial. 1, 2, 6, 24. So this is n factorial, yes? N factorial, I put it here. Do you know n factorial? N factorial means n times n minus 1 times n minus 2 up to 3, 2, 1. The product of all integers from 1 up to n. So that's the formula. And usually people prefer to write it nicely like this. And then I bring it back and make the exponent positive. So that's the formula for the nth order derivative. But it is not guaranteed. Most of the functions we cannot find the formula for the nth order derivative. Yes? Okay, so let me skip these two, and then there are two parts left, and if we have time, of course, we come back. This one is also simple, and that's the notion of normal and tangent lines. Where is this? Okay, about the tangent line, actually I talked about yesterday. So do you remember what was it? So if I have a graph of a function, if it is differentiable at this point, let me call it a, and if this function is f of x, then of course I told you what is this one then? This will be f of a. And this point t is called the point of tangency. I can draw the tangent line there. What was important to know about the tangent line was the slope of the tangent line. Do you remember what was it? The slope of this tangent line. So if I call it k value of this. So the k value is the derivative of the function calculated at the x coordinate of the point of tangency. Yes, that's the k value. And then I showed for you that the formula of the tangent line will be y minus f of a. This is something it's good to remember. Equals to k value, which is f prime of a times x minus a. This is called the tangent line, yes? Do you remember I told you about this formula yesterday? I talked. But there is also another thing which is called the normal line. Normal line means the line that is perpendicular to the tangent line. That is called the normal line. So if I ask you to draw the normal line at this point, you need to imagine the tangent line first, and then momentarily forget about the graph and draw a perpendicular line to it. Yes, this angle should be 90 degrees, and this is called normal at t. This is called tangent at t. Yes? Okay, but yes?
Do you need to remember the formulas for tangent and normal?
Yes.
Okay.
Either you derive it yourself, because you don't need to remember. If you remember, yesterday I told you that in high school we studied this as the equation of a line. The only thing you need to know is that k is the derivative. So instead of k you put derivative, but then m will be missing. In order to find m, you need to pick up this point and put it in the equation and find m. But because this is very common in this course, I would prefer to write it like this. Okay? So this is the equation of the tangent line. And by the way, in principle, you can, this is, I don't know, some high schools talk about this. For example, if I have a coordinate system, and if I have a line with k value k and a point on it, no matter which point, let me call it x naught and y naught. If I ask you what is the equation of this line, this becomes y minus y naught is equal to the k value x minus x naught. This is not only for the tangent, but tangent line is one particular form of line. So this is the formula I am using here. Okay, but can you tell me what will be the equation for the normal line? You learned something in high school. If two lines are perpendicular, what can I say about the slopes?
They have a product of -1.
The product of them should be -1. In other words, one of them is minus the reciprocal of the other one. So this means that if I ask you what is the equation of the normal line, because the normal line passes through the same point, so these two will not change. The only thing that will change is that I have a new slope. But what is my new slope? then the new slope is minus 1 over the old slope. Of course, here f prime of a should not be equal to 0. So this is the normal line. Yes? Is that understandable? So I am using this fact. If two lines are perpendicular to one another, if I take these slopes, multiply them, the product of the slope should be minus 1. Okay, and now we can actually solve some examples. Oops, I forgot to record this part. So these are the formulas that we use for the tangent and the normal. But be careful, here this is for the normal functions. I have given you an example here. If you see, this type of function is what? Is an implicit function. Yes, so you can use the same ideas for the implicit ones. Because we are running out of time, if you don't mind, in principle, pedagogically, I have to teach you this one first, or at least solve this one for you, and then jump to this one. But if you don't mind, let me jump to 12 immediately. Because I hope that you are not having troubles here, yes? So what you need to do for the question number 10, you just need to calculate the derivative of the function, which is a combination of product rule and the chain rule, and then just put them in the formula. Okay? So, in principle, I know I have to do it, but let me jump to the harder one. So if you see question number 12, determine equations of tangent and normal lines to this curve at this particular point 1 and 1. Okay? So that is the same idea, but combined with implicit differentiation. So that might be a little bit better example. So let me write it down here for you. So x sine, and then I have xy minus y squared equals to x squared minus 1. And the point is 1 and 1. First of all, do you think that this point is on this graph? Because this graph, I don't have any clue. You can use GeoGebra or any other software to draw this to see how this looks like. But is this point on this curve or not? How should I check that? Because you know that what I told you here, the point is on the curve. Yes? In principle, the point can be outside. By the way, that's also a good problem to think. If I give you this point and ask you to draw this tangent, this is a harder problem. Okay? So this is why I haven't seen this in your course, but this we had it in high school. Okay? So if I have a point outside and you want to draw a tangent, you should be in principle be able to do that. But the problem becomes harder than this. Okay? Because why this is harder? Because this derivative should be calculated at A. A is the point of tangency, x-coordinate of the point of tangency. So this is the point that I have to put here, but the problem is that this is missing, this is given. Yes? So that's a harder problem. So that's why I'm saying that usually you have to check that if this point lies on the curve. Is that correct or not? Let us check. Wherever you see x, put 1. Wherever you see y, put 1 again to see if this equation holds. If x is 1, the right hand side becomes 0. What happens to the left side? This becomes 1 minus 1. Sine of 0 is 0. So 0 is 0, so that's correct. I'm on the safe side. That's exactly the same type of problem. Okay? But now, what do you need? You need to calculate the derivative. Why? Because the derivative at that point is the slope. But because this function is implicit, I have to differentiate implicitly. How should I do that? I differentiate the left and I differentiate the right. The right hand side is simple, 2x. The left hand side is a product. The derivative of the first one is 1 times the second one plus the first one times the derivative of the second one. But the second one is a chain rule. So you have to take this u in your head sine of u becomes cosine of u, but multiplied by u prime. Yes? Okay, so I copy and paste this part. But this one I have to do, there is a prime here, you see? So this one becomes x cosine, x cosine xy minus y squared, and then multiplied by that. But this is a product rule. The derivative of the first one times the second one, plus the first one times the derivative of the second one, minus the derivative of that one is the chain rule, so 2y, y prime. You see, implicit differentiation might be a little bit confusing if you don't practice good enough. Okay. Do you remember it was very messy to calculate y prime? In principle, you should be able to do that. But my advice for you is that you don't have to suffer to do it algebraically, because I don't want the whole y prime. I want to calculate y prime at this particular point. One way is to find y prime algebraically and then replace x and y with 1 and 1. But because in anticipation of what is coming, I replace x and y with 1 and 1 right now. Yes? Is that understandable? Be careful. If y prime is wanted in its totality, in its entirety, you have to do algebra. But if you want to calculate it in one particular number, you still can find it and then replace, but you can also replace and then calculate. It doesn't matter. I will choose the second strategy. And you see, it will save you a lot of time. Because x and y are both equal to 1. So if I plug x equals to y equals to 1 in this relation, this becomes 0, because sine of 0 is 0. Cosine of 0 is 1, so it becomes 1. So you see, in that case, this becomes 0, this becomes 1. But then I have to put numbers there. Y is 1, x is 1, y is 1, x is 1. You see, much simpler. Yes? I replace x and y with 1 and 1 everywhere. And then I move 1 to the other side, so it becomes minus y prime is equal to 1. So what is y prime? Is minus 1. But if I ask you what is y prime here, to be honest, this is not completely correct. I have to write y prime at 1 is minus 1. This is the correct version of writing. Yes? Now, can you help me to write the tangent line? The tangent line has the same formula. So it becomes y minus the y value of the point of tangency, which is given to be 1, equals to my derivative, which is minus 1, times x minus the x coordinate. And I can simplify it. So y becomes 2 minus x. I multiplied that and I move minus 1 to the other side. So this is tangent. Yes? Now if I want to find the normal, what I need to do, I need to find the k value of the normal. So k value of the normal becomes what? Becomes minus 1 over y prime of 1. So it becomes 1. And then I put them in the same formula, so it becomes y minus 1. K value is 1 this time, x minus 1. So this, if I simplify it, y becomes equal to x normal. Yes? And let me give you a little bit of time. Are you confused or not?
No.
This is list of time. Confuses everyone. I hope that you at least understand something. Is that clear, what I'm doing? Yes? Okay. So So remember, whenever you have implicit differentiation, but you want to calculate at a particular number, instead of finding y prime algebraically first, and then replace first and find would be much simpler. Any questions? Okay. So what is your, because we will not be able to finish the last part that I am supposed to do. So now you have to decide, okay? Do you want to stay or not? Okay, or of course I will continue recording and I will publish it. So if you want to leave, you will not lose anything. But if everyone leaves, I will also leave. But if there is one person here, I will also stay here. So that's up to you. And
How long
please,
do you need?
pardon?
How long do you need?
Probably half an hour.
Okay.
No, you can have your lunch here if you want. I told you last time, okay? But I can give you 5 minutes to rest. Okay, we can do like this. If you want, you can move. But if I am here and you come back, I will continue. Otherwise, I will do it probably next time.
Is it important and worth it?
This is a hard question. I mean, is mathematics even important? The answer is yes, because whatever we are doing really depends on if you are using this Zoom in your iPad, that's a mathematical transformation. So whatever you learn in linear algebra is directly implemented. If you are using a spell check, it's called, metric spaces. So you have the spell check. So mathematics is in your life every day from the way that, the moment you open. But if you like it or not, that's a different story. But anyway, I will actually stop this recording and then I will start recording again, okay?